All right, let's dive right into this explainer where we're going to completely demystify Java. We'll be starting our journey from its vast global ecosystem, looking at how it powers the modern world, and taking it all the way down to the atomic level of your very first line of code. Whether you're completely new to programming or just looking to understand why Java became such a monumental force in software, you are exactly in the right place. To make sure we have a rock-solid foundation, here's our roadmap for today. First, we'll meet Java. Then, explore the Java ecosystem. We'll decode the 12 Java buzzwords, see how Java versus C++ stacks up, and finally, break down your first Java program.
All right, Section 1, Meet Java, Defining the Technology.
Most people just think of Java as a standard programming language, but it's actually two different things. Yes, it's a high-level, robust, object-oriented language, but crucially, it also acts as its very own platform. Because Java brings its own runtime environment, the JRE, and its own API, it literally functions as a self-contained environment living right inside your computer. Just a quick bit of history to set the stage here. Java was developed by James Gosling and his team at Sun Microsystems back in 1995. And here's a pretty fun fact for you. It wasn't actually supposed to be called Java. The team initially named it Oak, but as it turns out, Oak was already a registered company, so they had to pivot, eventually landing on the iconic name we all know today. Moving on to Section 2, the Java ecosystem. So where does Java actually live out in the real world? Well, the short answer is absolutely everywhere. Basically, Java is used to build four main types of applications. First up, standalone applications. These are your traditional installable desktop apps like media players or antivirus software. Second, we have web applications, running behind the scenes on servers to generate dynamic web pages. Third, things scale up with enterprise applications. We're talking massive, highly secure, heavy-duty stuff like banking systems. And finally, mobile applications, most famously, the core foundation of Android devices. Now, how does Java handle all these vastly different tasks without turning into a bloated, chaotic mess? Well, it's intelligently split up into four specialized platforms, or editions. You've got Java SE, the standard edition, which gives you those core APIs and object-oriented tools. Then there's Java EE, the enterprise edition, which builds right on top of SE, specifically for complex web and enterprise apps. If you're building for mobile, you'd grab Java ME, the micro edition. And lastly, JavaFX, which is your go-to toolkit for whipping up lightweight, rich internet applications with really sleek user interfaces. All right, Section 3, 12 Java buzzwords. Let's look at the fundamental DNA of the language. So here are the first 6 pillars of Java's design. It was intentionally built to be simple, borrowing syntax from C++ so it's easy to pick up, but leaving the super complicated stuff behind. It's objects-oriented, meaning everything is built around objects that neatly combine data and behavior. It's portable and platform-independent, which is a massive deal we'll talk about in just a second. But honestly, what really makes it shine is how secured and robust it is. It runs your programs safely inside a virtual machine sandbox and uses automatic garbage collection. Basically, it automatically cleans up unused memory for you so your computer doesn't suddenly crash. Pretty cool, right? Now, the next 6 buzzwords really highlight Java's raw operational power. It is architecture neutral, so things like data sizes stay fixed no matter what hardware you're running on. It's interpreted and delivers high performance. But the real game changer, it is multi-threaded. This means your programs can juggle multiple tasks concurrently, sharing memory without stepping on each other's toes, which is an absolute must for modern web apps. Throw in distributed and dynamic, and you've got an incredibly versatile tool. All of this leads to one crucial point, famously summed up in the industry as write once, run anywhere, or WORA. Because of its platform independence, a developer can write their code on a standard Windows machine, and that exact same compiled bytecode can be handed off and executed flawlessly on a Mac, Linux, or Sun Solaris system. You don't have to change a single line of code. It just works. Which brings us to Section 4, Java versus C++, contrasting the giants. To really appreciate Java's superpowers, we have to look at what programmers were using before it. The biggest differentiator here is platform dependency. Back in the early 90s, coding in C++ meant dealing with major hardware constraints. Your C++ compiler turned code straight into machine code, permanently locking it to whatever specific operating system and hardware it was built on.
Java bypassed this entirely by using both a compiler and an interpreter. The compiler translates your source code into intermediate bytecode first. Then, the Java interpreter takes that bytecode and runs it on any platform at runtime. That right there is the secret sauce to breaking free from hardware lock-in.
And to make things even more robust and secure, Java completely stripped away the headache-inducing baggage of C++. It just outright dropped support for the goto statement. It ditched multiple inheritance through classes to prevent code ambiguity, opting to use interfaces instead. And maybe most importantly, it restricted explicit pointers. In C++, bad pointer management was notorious for causing massive security flaws and spectacular system crashes. Java handles all those pointers internally, keeping the developer and the user's computer safe and sound.
Finally, Section 5, your first Java program. Let's zoom all the way down to the atomic code.
When you look at a basic Hello World program side by side with C++, I know the Java version can look a little daunting at first glance. That cluster of words in there, public static void main, yeah, that is notoriously intimidating for beginners. It honestly looks like a foreign language. But remember, Java was engineered to be simple and logical. It's really just a linguistic translation exercise. Let's break it down word by word. Step by step, the mystery totally vanishes. Public is just an access modifier. It simply tells the system, hey, this code is visible to everyone. Static is a brilliant keyword that lets the Java virtual machine execute the main method without having to create an object first, which saves a ton of memory. Void just means this specific method won't return any value back to the system when it's finished. Main is exactly what it sounds like, the absolute starting line, the main entry point for your program. And system.out.println, that's simply the command you use to print your text right onto the screen. Simple as that.
And there you have it. You now possess a rock-solid foundation. You understand the vast ecosystem Java lives in, the fundamental buzzwords that define its highly secure, portable architecture, and you've even dissected its syntax down to the atomic level. You are completely empowered to open up Notepad, write your very own class, and start typing out your future. So the only question left for you is this: what application are you going to build now that you speak the language? Thanks so much for joining me for this explainer, and keep learning.